At XPENG's recent launch event, a figure walked gracefully onto the stage. Her steps were natural, her posture confident, so lifelike that many in the audience gasped. No way. It must be a human inside. The next day, XPENG's CEO revealed the truth. It wasn't a person. A humanoid robot with muscle-like mechanical design, about 60 joints and nearly 200 degrees of freedom. Engineered to move with human-like precision. Each motion blurred the line between man and machine and marked how far robotics has evolved. Iron's lifelike motion may look effortless, but deep inside its frame lies the true source of its vitality: hundreds of high-performance circular connectors. Power connectors deliver constant current to motors and sensors. Signal connectors carry AI commands across control boards in real time. Hybrid connectors integrate power and data in compact modules. Each connection decides whether the robot performs flawlessly or falters. As iron ignited global discussions, a deeper question emerged. Could humanoid robots soon enter mass production? By 2026, humanoid robotics may no longer be confined to research labs. From industrial automation to intelligent logistics and service systems, robots will face longer hours, higher torque, and more complex demands. This evolution will push connectors to new limits: higher current density for compact power modules, faster data transfer for synchronized motion control, greater durability for continuous operation. At Weipu, we believe the intelligence of tomorrow's machines depends on the reliability of today's connections. Behind every robot that learns, walks, and creates lies an unseen neural network made of connectors. As humanoid robotics transitions from prototype to mass production, the question is no longer if, but when. To all technology innovators and manufacturers, as you prepare for next-generation robotic production, is your connector supply ready to support that future? Weipu Connectors. Power. Signal. Connection to the future.